In this segment, we consider the differential equation, second derivative of y plus k squared y is equal to 0. We saw previously that y is equal to a cos kx plus b sin kx is a solution to this. In some cases, so a and b are arbitrary constants, and with only this differential equation, you would leave the answer this form y the way it is. Okay, and so you would not be able to determine what a and b were, or rather, a and b could have infinitely many values, and you would, whatever values for a and b you had, they would be they would give you solutions to this differential equation. Okay. On the other hand, supposing that you're given something like this, you have second derivative of y plus 64y is equal to 0, and you are given the initial information that y of 0 equals 0.7, and the first derivative of y when x equals 0 is 0. So this has the form d2y by dx squared plus k squared y is equal to 0, where k is equal to 8. Okay? So then we have a solution of the form we saw before, that a solution would be of the form y of x equals a cos of 8x plus b sine of 8x. Now let's apply the first condition. Y of 0 is some fixed value. So let's put in x is equal to 0 and see what happens. We have y of 0 is equal to a times cos of 8 times 0 plus b sine of 8 times 0, which is a cos of 0 plus b sine of 0. Now cos of 0 is 1, and sine of 0 is 0, so what we're left with was a. So y of 0 is equal to a, and we were given that y of 0 is equal to 0.7. So a is equal to 0.7. So now we know that our y of x is of the form y of x equals 0.7 cos of 8x plus, we don't know anything about b yet, b sine of 8x. Now further, we were given that the first derivative when x is equal to 0 is 0. So we take the derivative of this y of x, and we get minus 5 point, right? Remember, the derivative of cos 8x is minus sine of 8x times 8. So the derivative of the first term, of the first summand, is minus 5.6 sine of 8x. And the derivative of sine of 8x is 8 cos of 8x. So the second summand gives us 8b times cos of 8x. So that's what the first derivative of y is. Now we were given that the first derivative of y is equal to 0. So let's put in x is equal to 0. Y prime of 0 is minus 5.6 sine of 8 times 0 plus 8b times the cos of 8.0. Now the sine of 8.0 is this, of 8 times 0 is sine of 0 is 0, so that term goes away. And the cos of 8 times 0 is the cos of 0, which is 1. So I'm left with 8b. And this is the y prime of 0, so that we were told was equal to 0. So 8b is equal to 0, which implies that b is equal to 0. That means then that y of x is equal to a, which was 0.7, cos of 8x, plus 0 times sine of 8x, so we don't bother to write the 0 term, and we get y of x equals 0.7 cos of 8x. So if you just had the differential equation without any other information, you would have these two arbitrary constants, a and b. If you're given the initial value of the function at x equals 0, and you are also given the initial value of the first derivative of the function at x equals 0, and then you can solve for a and b and get a specific function as the answer.